So you can see we collaborated with UNM, New Mexico Tech, the Bureau of Geology, the Geological Survey, the Office of the State Engineer, and put together this tool that brings together the main fluxes and storage components of water in New Mexico at 4 different scales: counties, planning regions, river basins, and the state. The green rectangle in the middle here is corresponds to the about 3.7 million acre feet a year of water use that's compiled by the Office of the State Engineer in terms of water use by categories report. And this model compiles about 30 million data points to show our historic period from 1975 to 2018 and estimates some future changes until 2099. And it's really important to understand, for example, just this groundwater storage picture. If you compare Lee County in blue with Socorro County in red, the Lee County does not have access to a river that recharges groundwater. So you look at the depletion in that location, it's essentially leftover fossil groundwater, and you'll see this continual decline basically because there's no recharge. On the other hand, if you look at Socorro, where the Rio Grande is running through the county, we saw gradual increases in groundwater storage. This is in thousands of acre feet a year, until the 90s when that turned around and we saw gradual decreases. So it's very important to consider the recharge as you consider groundwater. And this just shows another picture comparing the basin. The Rio Grande is outlined in black, and it fluctuates. Some years it goes up, some years it goes down. We had more of a declining trend in the 90s. But then if you look by county, in Rio Arriba, the fluctuations are around 0, and we have a general long-term equilibrium in groundwater storage. In Bernalillo, there was depletion until San Juan Chama turned on, and then less depletion. And then Doñana, or the lower Rio Grande, we see decreasing groundwater storage and ongoing fluctuations. So it really changes depending where you are. And this is actually reflected Senator Udall's comments on the changing runoff. We see less surface water really starting in the late 90s and 2000s, where there's less surface water withdrawals because there's less surface water available. This is in Doñana in orange. And then that causes a concomitant increase in groundwater withdrawals. And we see that in Bernalillo in blue, we don't have that same situation. Surface water withdrawals actually went up a little due to the San Juan Chama diversion, and groundwater withdrawals went down, while the Rio Arriba doesn't really have increasing groundwater withdrawals. And we'll talk about groundwater returns in this slide. If you look at the total surface and groundwater withdrawals in Doñana County, they've gone down. Return flow in red has gone down. This is in thousands of acre feet again from 1975 to 2018, using the statewide water budget again. Return flows, where water goes back to the river through surface or groundwater, mainly groundwater recharge, has gone down because of changing evapotranspiration and changing irrigation technology. It doesn't make sense to have as much flood recharge if you're using groundwater that's pumped. But really interestingly, the depletions, the actual water consumed and sent back to the atmosphere, is more or less stable. That's the green line here. So we can actually use that information to guide our planning. And the last slide I have just shows that groundwater storage change is that the end, Mark? Is that beep? Anyway, if you look at the groundwater diversions, high efficiency agriculture uses less groundwater. That's over on the upper right. And we can actually look to the future, including climate change and variability. We can actually make a difference with high efficiency agriculture and reduce our long-term groundwater storage depletion. So we just are kind of touting the idea of research to guide our policy and our technology and our changes. So that concludes my brief slides on our statewide water budget, our brief tour of the water budget.